Hello, I'm Tomer Morad from Synopsys, and I recently joined Synopsys through an acquisition of Concertio, a company that I co-founded. And today, I want to speak about automatic LLVM compiler flag mining. So, what does it mean? So we know that LLVM compiler flags, as you might know, there are more than 1,000 flags throughout the stack of LLVM. And the idea is that if you choose the right flag out of these 1,000 and use them correctly, you can get great performance gains, and it's easy, right? You just add flags to your compilation, and you don't have to do anything else. You don't have to refactor and things like that. So there's a huge potential, but if you look at all of these flags and try to brute force your way into it, it's going to be impossible because there are more than 10 to the 300 possible combinations, way beyond the human capacity. So you need a tool to do that and to do it smartly. And I want to talk to you today about Optimizer Studio and how it automates the process of LLVM compiler flag mining. So let's say you're an engineer and you want to mine your compiler flag in your application. So you would typically go through this process. So one, you would prepare your benchmark. Let's say you already have it, or spec benchmark that reports a score or something else, or you would prepare something, but that would be your benchmark. Then you choose your optimization target. Maybe it's minimizing time of your application. Maybe it's maximizing the score of spec. Whatever it is, this is your goal. Then you define your tunable. In this case of VM, let's say you want to try between -0.3 and -0.2. You don't know what's better, you want to try it. So you would select your system configuration, meaning you would choose your flags, then you would compile your application, you would run it, and you would measure the results and see how much you would get. And then you would select a different system configuration, run it again and again and again until you find some configuration that you are happy with the results and you report it. So that would be the manual way. In the automated way, this whole right part is completely automated, including the loop. So Optimizer Studio has advanced search algorithms, evolution-based, greedy-based, and others that help you get quickly to the best or approaching the best result. It also has ways to deal with noise and variability of the results and to allow you to get scientifically proven results. And all of the experiment data are exported into an experiment management system, a cloud-based system where you can view results, visualize them, generate all kinds of analysis and insights, and so on. In terms of the tunables, so in Optimizer Studio, if you use LLVM, you can just, with a one-liner, import all the relevant flags, and you get around 300 and counting pre-approved and pre-checked flags that we already support. And we also support other flags and tunables throughout the tech stack, thousands of them. In terms of the goal of the optimization, so it can be simple or single objective like minimizing time, or it could be multiple objective like I want to maximize the performance within a power budget. So that is also possible. And in terms of the benchmarking tools, so have integrations to spec benchmarks, MLPerf, and others, so we can get working with those kinds of things pretty quickly, but any kind of benchmark is easy to connect Optimizer Studio. But the main idea of automating this process is that you get higher performance compared to doing things manually. The tuning time goes down and the tuning efforts are almost eliminated because with the push of a button, you can just go home, come back later, the day after you can get the results. And the main features that I wanted to point out in this very quick lightning talk that are relevant are, one, we support flags for LLVM 4 through 13. We also support other compilers and other stack tunables like OS tunables, processor tunables, database tunables, and so on, thousands of them. We support multiple algorithms, like evolution, grid. Refinement is an algorithm that takes a vector of many flags and minimizes that to only those flags that are influential. Sensitivity means a sensitivity analysis to allow you to run sweeps. We have a full-blown experiment management system with automated documentation, and collaborative tuning means that you can share your experiments with your peers and they can see what you're doing and work together. So if you'd like to hear more, visit us on our website. This is the Concertio website until we set it up at Synopsys, or email me. Thank you very much.